First things first, let's first be clear on what is a perfect square. So, let's say we have 25. 25 is considered perfect square because its factors are 5 and 5. Also, 49 is considered a perfect square because its factors are 7 and 7, or 7 squared. Here, 5 squared. So as you observe, how can we describe a perfect square? So based on this example, perfect square can be classified perfect square if its factors are repeated versions of it. Let's say this 5. Since 5 repeats here, then you multiply them, get it results to 25. Thus 25 is a perfect square. Same is true with polynomials. So in here we have trinomial. So trinomial is a polynomial with 3 terms. So let's say x squared plus 2x plus 1. This is a trinomial, while x squared plus 1 is only a binomial. Right? So you need to just remember that terms are separated by either plus or minus sign. So here, there's only one plus sign. So this is binomial, while above is trinomial. So that's trinomial, and that's perfect square. So now, what is a perfect square trinomial? In order to understand that, let's create it. Suppose we have 3x plus 1, then times 3x plus 1, or that's the same as saying 3x plus 1 squared. If we expand that by the FOIL method, or by simply distributing each term to the other term, other parenthesis, we can get 3 times 3 is 9, and x times x is x squared, plus the outer, which is 3x, and then the inner, which is 3x, so that's 6x, and then plus the outermost, or the last term, 1 times 1 is 1. So now we've got this. This is now a perfect square. Why? Because its factors are 3x plus 1 and its repeated version. So 3x plus 1 times 3x plus 1 is its factors. So now, there are certain problems that they will ask you, or they will let a, this is a here, right? And then this is b here. The coefficient of x squared is a. The coefficient of x is b. The constant is c. So something like that. They will let this be unknown, or it could be a or b or c. They will ask you about that, and so they will let this a become kx squared, something like that, 6x plus 1. And now they will ask you what is the value of this k, so that this whole term becomes a perfect square. So now that's why we are here on this video. We are going to discuss how to solve that. So since we have this, we know that this is a perfect square. Certainly, it should follow this form. So if we have a plus b squared, so this is a term multiplied or added to another term, and then squared. They're both squared. That's a plus b times a plus b. So that's a squared plus 2ab plus b squared. In order for this polynomial or trinomial to become a perfect square, this should follow this format, alright? Because this is the very general term for being a perfect square trinomial. Having the first term squared, the second term twice the product of the first and second term, and then the last term is the square of the last term. So that's the first step to solve this problem. So it should follow this format, and then now that these two should be equal together, we can equate both terms term by term. So how is that? it will then become kx squared is equal to a squared. While 2ab, so this term here, this term, 6x will become 2ab. So now, if we divide both sides by 6, and then we know that, what's b? Our b here, b squared, is equal to 1, right? Here. So let's again recall, equating all these terms together, we create equations. So first equation is kx squared is equal to a squared, 2ab is equal to 6x on our problem here. And then b squared is equal to 1. Alright? So now, our very goal here, now that we have these systems of equations, so our very goal is to find what's k. And so by by substitution, or by solving one equation and then substituting it to another equation, we can now solve for k. So let's say we start here at this equation. So since 1 is equal to b squared, so b could either be plus minus 1, positive or negative 1. And so now that we have b, we can plug that in to this equation below, above this one. So let's interchange. We have b. So if we insert b here, the value of b, which is 1 for this case, 2a, then here 6x. Then for the other one, as 6x equals 2a negative 1, we'll then have, let's make it be 2a negative 1. So we'll then have, we will need to solve for a here, or x, depending on what you want, and then substitute that to this equation to finally solve for k. So watch. 6x, so we will replace a, so a would become 6x over 2, right? Hope you see that. You divide it by 2 and divide it by 2. It's like that. And so now, a is equal to 3x. So we've got this. And then, for this one, since a is 2a is equal to 6x, same thing, negative. So it will become negative 2a 6x. Just solve for a. So a is equal to 6x divided by negative 2. So a is negative 3 on this case. So there's two values for a. And so now that we have this, all we need to do is plug that in to this to finally find for k. So let's first start with at a equals 3x. And then for the other one, at a equals negative 3x. Here, it has x. And so with that, kx squared is equal to this a. So that's 3x squared. So now what? K is equal to, kx squared is equal to 3x times 3x, or 3x close in quantity squared is 9x squared. And dividing both sides by x squared, finally, we've got 9. And if we do in the other side, negative 3x, so this would be kx squared is equal to a squared, so negative 3x squared. So as you can see, it will give the same because negative 3x times negative 3x is 9x, and kx squared. And so k is indeed 9. So you see, we've just solved for the unknown value, which in terms, this one. our perfect square trinomial. So here we have k, and we assume that we don't know that 9. So that's it. That's how you solve for problems like this if the unknown is a. So if the unknown is b, let's try if we can still get 6. So still using those equations we got, so 1 equals b squared, so then 6x equals 2ab to become a perfect square trinomial. So forgive me because the explanation is so long, but I will assure you the process is just as easy if you get it. I mean, it's pretty straightforward that if you want to solve this if you assume that this is a perfect square, then this should follow this format here. That because this is a perfect square, general way to represent a perfect square trinomial, and if you have a given trinomial, you should let this follow this format, and by that it should follow this format. Therefore, every term should be equal to each other, right? So now we got this. So 1 is equal to b squared, 6x equals to 2ab, and then 9x squared. So 9x squared. Suppose we don't know what 6. So this is k here. So k should be 6. And let's check if we get that right. So and then 9x squared should be equal to a squared. So all we did was create an equation. And so this should be our final step. So what's b? B could be plus minus 1. And as we solved a while ago, if b is positive or if b is negative, doesn't matter here, because still it gets squared. So we can just use b as 1. So here 2a, so this is 1 here, that's b. And then solving for a here, a, all we need to do is take the square root of 9x squared, and still we should get positive negative 3x, so that's a. And then again, negative won't matter, so that ax should be a is 3x, so 2 times 3x, and then here x. With that, k is equal to 6. Alright, k is 6. So that's it. This is how you solve problems that ask you for what's k, and then you are given or provided that the trinomial is a perfect square. So again, in summary, the problem asks you on k could be the coefficients. If the problem asks you the coefficient, let's say this is k, this could be, a could be k, b could be k, or c could be k. Just equate it to the general formula for perfect square trinomial. So since perfect square trinomial is in the form like this, just equate that ax squared plus bx plus c. And then since they are equal, these terms are also equal. So a squared is equal to ax squared, and then 2ab is equal to bx, and then c squared is equal to c. Alright? And with this equations, you can now solve for what's k. Because this could become k, this could become k, and this could become k. So that's it. I hope you got something here. Now it's your turn to solve this one. Good luck and enjoy. Thanks for watching. Peace out.